Now, in part A, we want to find the inverse of f. We'll do that by switching around the x and the y. So we'll have x equals the square root of y minus 1. We'll now solve for y by squaring both sides. When I do that, I get x squared is equal to y minus 1. Adding 1 to both sides gives us x squared plus 1 equals y. I'll rewrite this as y equals x squared plus 1. And so the inverse is x squared plus 1. Now, one thing to keep in mind, if the original function was defined for x is greater than or equal to 1, so this function is defined for x is greater than or equal to 0. The reason for that is for the original function, when x is greater than or equal to 1, the output or the range is greater than or equal to 0. So we switch those around when we find the inverse. For part B, we need to graph f of x and f inverse of x. I've already graphed f of x, which is the square root of x minus 1. That is this graph, and I'll label it f. To find f inverse, we could graph x squared plus 1, where x is greater than or equal to 0, or we could just rearrange the coordinates of points on the original graph and graph those. So for example, this point is 1, 0, so on the inverse it would be 0, 1. This point is 2, 1, so on the inverse it would be 1, 2. And finally, this point is 5, 2, so on the inverse it would be 2, 5. I can then connect those points to draw the graph of f inverse. Again, it's worth noting that those two graphs are symmetric about the line y equals x.